All right, hell yeah. So, what I don't like is technical language. You know what I mean? That's not just obvious. And then technical language can sometimes, turn you off to like further learning. So, this word frequency, I don't know. You know what I mean? What is frequency? It's just like one rotation a second. So revolution is a type of frequency, like revolutions, well, I guess revolutions per second. So frequency has the units of revolutions per a unit of time. And so it gets the letter F. So we're going to kind of work our way through here. And then you have angular velocity, which is, kind of the angle that gets played out per time. You know what I mean? So, like, what's the angles of a circle? And this is also what I don't like, because even you can graduate without fully, embracing what a radian is, and that's crazy because it's the most fundamental. It's like even this is like, do you think a radian is an angle? And for the smart people, they're just like, hell yeah, what are you talking about? A radian is always an angle. You know what I mean? But, I mean, I don't know if this is just an American thing, but when you have an angle, people are just like, hey, that's like 30 degrees, that's 60 degrees. No one even talks and being like, you know what I mean? That's why I use some markers. So a half a radian is 30 degrees, and that's where, you can stop your you can use small angle up to a half a radian. And I'm not going to go into that, but 1 radian is about 60 degrees. So it's just good to, and then where do you come up with that? And then even just the fact that if you have 6 radians, that's a full circle. I think a lot of math, physics, engineers can graduate without just having this thought in their head that if I hear the word 6 radians, that booyah, I have a full circle. You know what I mean? If someone says 12 radians, that's 2 circles. If someone says 10 radians, you should just be like, hell yeah, that's 2 circles. 2 revolutions. Okay, so sweet. But yeah, so that's why I think when people talk in radians, we don't compare it to anything. I used like what is it, Shaun White? You know what I mean? Hell yeah. Do a 2 radian. You know what I mean? Do a 360. No, we say 360. We say 720. And so I can't just rattle off the radians for, you'd have 360, double that 720. So yeah, it's 4 pi radians. Hell yeah, so do a 4 pi radian. And then isn't a 900, just 2.5? Like Tony Hawk, what did he do? You know what I mean? If it's 4 pi, say it's 5 pi radians. You know what I mean? So hell yeah, I should make a meme that Tony Hawk, because I remember that day. I had TV. We all had TV, cable. Hell yeah, and we just watched it all the time. So I didn't miss Tony Hawk's 900. Hell yeah, it was probably just one Saturday, just depressed. But hell yeah, he did it. He wasn't depressed that day. Alright, so hell yeah. So 5 pi radians, and I might even have that wrong. I have no way to double check that. Alright, but we got to make less jokes and just kind of move on. So hell yeah. So angular velocity, even like, what's that again? Well, it's an angle that's being played out over time. Angular velocity might think like it's actually tangential velocity, but no, you have to multiply it by the radius. And because radians are something special, I'm not going to go into that, but you know what I mean? And it's like I have a hard time rattling it off all the time, you know what I mean? I just know that when you have a circle, you can take a radius and then cut a string the length of the radius and then start draping it around the circle. And then cut more strings the length of the radius. And you'll drape about 6. You'll drape 6.28 strings around the circle. That's 2 pi, 6.28. And then, I can't not say this, but pi is 3.14, close enough. Double that is 6.28. You know what I mean? 3.14, just all the numbers get doubled. So that's a fairly easy one to keep in your head. All right, so let's get back to this frequency thing. So the frequency is, revolutions per second. So let's say the frequency is just 1 revolution every second. Cool. how many angles are what's the angle that's gonna get played out every second? Well, I don't know. I'm gonna use 360 degrees. I'm gonna think, hey, 360 degrees is the angle that's getting played out every second. Every second, we're gonna spin another 360 degrees. But we got to work in radians, so that's 2 pi. So even though, like, I don't know, I don't like these formulas. They don't pop to me, from a fundamental perspective. But this says if my frequency is 1 revolution per second, then in 1 revolution we have these 2 pi radians. You know what I mean? Hell yeah, next time I go skiing, I'm going to try a 2 pi radian. Hell yeah. And then so that's an angle. And because I just multiplied it, because this has units of per second, 1 revolution per second, and this is, this is actually 2 pi radians per revolution. So this is a ratio of angles per 1 revolution, and this is 1 revolution per time. So the revolutions can cancel, and we get radians per second. So that's how you get that. Hell yeah. But I was just thinking, it's just like, well, you should have an equation. It's just like, well, this doesn't look like a fundamental equation, even though it is. And so we go down a little rabbit hole of being like, isn't there a term for this? And so what do we say? Are degrees just, so 360 degrees. Because it says radians are dimensionless. Are degrees just as dimensionless? Yeah. But SI says radians. And it's just because radians is related to the radius. If I say this is playing out 1 radian up to about 60 degrees, then what does that mean? That it means that if I'm somewhere on a circle, doesn't matter where, but then I go around a circle like 1 radian, that means that I traveled a path that's equal to the radius. So that's kind of in reverse of what we said. Make a circle, cut a string to be the radius, and then drape it along that circle. You'll get to be 1 radian. Okay, hell yeah. You can't do that for degrees. But you could have said an angle is 1 diameter. Just go twice. You go 2 radians, and now you've gone 1 diameter. You know what I mean? We could call that 1. And if we called that 1 diameters, it'd be the same thing. You know what I mean? We could talk about diameters. Instead of radians, we'd call them, I don't know what you'd call them. All right. So, but this 2 pi does get a symbol, the Greek letter tau. And I was like, okay, is this Greek letter tau also can be used to represent degrees? And I think it's no. But can the letter tau also be used to represent 360? Sure. The Greek letter tau can be used to represent 360 degrees. It's just commonplace to represent it as in radians. And so is tau representing the angle of 1 full revolution called a period? I was just curious about that. No, tau is not called the period. While both relate to a full cycle or revolution, they are fundamentally different concepts. I don't really explore that. I'm just like, okay, at least this tau can be used as 2 pi and 2 pi radians. It's a common. And so what is it actually? It's called the circle constant. So I can dig that. You know what I mean? When using this letter tau, it's going to be used to represent 2 pi as a circle constant. Now, this Google, I don't know how accurate it is. It did say you could use it for degrees. I wouldn't do that because you'll see this equation. Because when tau is used to represent 360 degrees of a circle, when used to represent the angle of a full circle, 360 degrees, tau is called the circle constant. Yeah, so if you use tau for 360, it's still the circle constant, but the value of tau is still 2 pi radians. You know what I mean? So even if you, so that's, if you use this equation that said C is equal to TR, then, and this was in degrees, you would have to have a constant out here that would divide by 360 and then multiply by 2 pi. Because your tau for this would be, this equation doesn't work. This equation literally does not work if you put the number 360 here, it doesn't work. If you put the number 2 pi here and multiply by the radius of 1 meter, if you have a circle with a radius of 1 meter, the circumference is going to be 2 pi. That's going to be 6.28 meters in circumference. And so, yeah, but if you put 360 degrees here, well, you have to divide by 360 degrees and then multiply by 2 pi. So if you do have this as degrees, I was saying, well, yeah, you could just put a constant k out here, but that constant k would be 2 pi divided by 360. So, so that's not very useful to have this. So tau, I would just say, is 2 pi radians. I mean, it should never be used as 360 because if you put 360 here, you would have to have some sort of ratio out here to change those units. And that's it. So in the formula, c is equal to tau times radius, that's the one we just talked about, where tau is in degrees, is a constant needed to convert the radians. And of course, you know what I mean, you can't just have this formula and throw 360 degrees, or the number 360, and expect to get a accurate value for the circumference. All right, so that was just a little bit of relating, you know, this frequency, because I'm finally at the point where it's just like, yeah, I got to buckle down and kind of remember what this frequency is as something that, you know, changes in a period. And, yeah, you know what I mean? And circles are a good way to represent that. If something is constantly changing at a constant rate, that's why we use this term of angular velocity, because if that angular velocity is constant, then we're going to have a constant angle, and we're going to go through that cycle just like a spinning drill. And frequency can be revolutions per second. So yes, frequency can be measured in revolutions per second. How is frequency typically described in units? And maybe we'll end there. Typically described in units. Frequency is usually described in hertz, which is 1 cycle. Yes, so this word cycle, I'm glad I mentioned that, just because some things don't spin in a revolution, but they repeat themselves. You know, it's going to go up and down, on and off. And, you know, sine waves are classic of this, and sine waves are analogous to a rotating circle, but they, you know, waves are analogous to circles, but a wave isn't necessarily spinning in a circle. It's its own thing. Hopefully I'm saying that right. So this term cycle would get used. All right, hell yeah. I think that's a good enough video. I'm going to end it there. Thanks for joining me. Hell yeah.